Hello, good day, students. This is Dr. Jacob. Today we are going to briefly explore Arduino Uno, which is a chip that we are going to use to demonstrate our assembly language and embedded language, embedded C programming. As we previously discussed in our last class, we said that you cannot just learn assembly language programming or embedded C programming without the use of a hardware, which we say that the brain of any hardware you're going to program is microcontroller, and sometimes we refer it as microcontroller programming. So as you are seeing now is a typical Arduino Uno system on chip, SoC. I explained to you why it is called SoC. You can see that there is a microcontroller in this system on chip. This microcontroller has already been embedded on this system on chip. We explained the different families of microcontroller, which we say we have AVR, AR embed, 8051, and here we say that Arduino falls in the family of AVR. In AVR family, we have different, in AVR microcontroller, we have different families too. We say we have the Art Tiny family, and we have the Art Mega family. Arduino falls within the Art Mega family, and this type is called Art Mega 32HP. This is the particular make of this microcontroller. Art Mega 32HP. You can also search it online if you don't have the physical Arduino SoC with you. You can explore it online. So this is called system on chip because everything has been built for you. Since we are in computer science, we don't need to give ourselves headache in building this hardware here. The input and output pins have already been fixed with a socket. Here we have 0 to 13 pins, which are digital pins. If you look at it clearly, you will see that we have digital pins from 0 to 13. So these pins are multipurpose pins. This side you see the analog pins. So the ADC, analog to digital converter, has also been embedded here. You can see it if you are using analog sensors like light sensor, temperature sensors. There are examples of analog sensors. You can connect it to this pin, and allow you to read digital values from 0 to 1, 0, 2, 3. Then you have the power pins this side. So these digital pins can also be, if you look at the pin 3, 5, 6, 9, 10, 11, 9, 10, 11, they are PWM pins, pulse width modulation, which you can use to control dimming LED or robotic design. You also have the power pin there, the ground pin. There's one that you see is labeled A-ref. A-ref pin is when you are programming an analog sensor and the demand require a power capacity or power requirement that is different from the one we have in these power pins. In power pins, we have the 5 volts pin and 3.3 volt pins. When you are using our programming analog sensor, the default power pin is a 3.3 volts, but when there is a requirement beyond that, the RF pin can be used as an connect to external power for programming your analog sensor. We also have the communication pins. Pin 1, when you have the RS and the TS, receiver and transmitter pin. These are serial communication pin. When you want to connect your Arduino board to your computer system, you are going to connect it via this place, the USB port, through this connector. This side we go to your computer USB, while this side will be connected to your Arduino board. So the communication from your Arduino to your system is done through serial communication, and see where it is configured or embedded in these circuits, the RS and TS. If you are also using external communication, there are other different communication. We have the onboard communication, I2S, inter-integrated circuit, ISP, and ISP is also a wired communication protocol. UARTs, which communicate through the TS and RS. You can also use wireless communication. For instance, if you are going to program a wireless sensor device whereby we need to read data from the wirelessly to the system, we have other external communication like this ESP. We have different ESP32 and ESP 8266. This is a typical, they are all Wi-Fi modules that you can use, which can be transmitted through this RS and TS. So the RS of the Wi-Fi module will be connected to the TS of your board here, and the TS of your ES module will be connected to the RS. Then there are other pins here, which for instance this IC here that is called ICSP. It communicates with the pin, some pins there like the pin 10, pin 12 through pin 10, when you want to communicate with external devices, which we are going to actually practicalize with the project assignment. Here last class we talk about the oscillator circuit, which if you are using 8051, you need to build this thing by yourself. This is not engineering or computer architecture class, so that's why we choose to use this board that everything has been built for us. This is a power pin. When you design a board, a wireless sensor design, this is where you are going to get the external power through the power supply system. Then this one goes to your laptop or computer system. If you want to use maybe in production environment, it is only this microcontroller that is usually used. When external communication and programming is done, want to be done, when you want to program only this microcontroller, this ICSP pins are used in combination with the communication pins here to enable you code directly to this microcontroller. So this is just a brief of the Arduino board. I will send a link to you where you get the architecture clearly through the data sheet. You can study the data sheet. Anything controller you want to program, it is very important to study the data sheet, and I'm going to send the data sheet in the comment section of this video so that you can download this or click the link to study more about the board. Now this is what we are going to use to program our you can use both embedded C and assembly language to program this controller. Thanks for listening.